Thank you, my dear participants. Yesterday we were talking about creation of vectors and different form of vectors. Now today I shall talk about factor vector. So factor is like the concept of factors in the design of experiments. Factor talk with labels. For example, gender is a factor and it has labels male and female, and it has two labels and their labels are male and female. Similarly, income is also a factor because it is a categorical variable. So, income could be low income, medium income and high income. So, factor actually these terminologies have been taken from design of experiment. In design of experiment, what we do that we apply different fertilizers and so these fertilizers, say for example, if we apply nitrogen 80 kg per hectare and 120 kg per hectare. So this nitrogen has two levels of applications and that is 80 kg and 120 kg. Similarly, phosphorus, if we are applying phosphorus also, say for example 10 kg per hectare and 20 kg per hectare. So these are the two levels of the factor nitrogen, and response is yield. So we want to seek what these factors are affecting on the response, and response is yield. So here in R, factor is a categorical variable. Say for example, we can create a factor like GRP is equal to C, control, treatment, control, treatment. So if we run this, we are having control, and if we print this, it is a character vector. At present it is a character vector, and you see that it has double quotes: control, treatment, control, treatment. It has double. When we convert into a factor by using the function factor, it is FGRP, another object has been defined, new object, and that is after converting it into the factor. So FGRP is equal to factor GRP. And here if you print this, it shows labels, control and treatment. So here the vector is control, and here it gives without quotes. So after converting into a factor, it prints control, treatment, and it does not have double quotes. Whereas in earlier, before converting it into a factor, it was giving double quotes, but here it is not double quote. And labels is control and treatment. See, factors are efficient ways to storing data. Say for example, this control and treatment, they can be converted into an integer as dot integer. It is 1. 1 stands for control, 2 stands for treatment, 1 stands for control, and so this is the efficient way of storing the data. Now labels of the factor, the function is labels. So here labels are control and treatment, they are two labels. If we make use of table function is nothing but it generates frequency table, and it is a very general purpose function and it is very efficient function. So this factor vector has control, treatment. So we can make a frequency table, and then function is table. Now there are two controls and two treatments, and if we go for bar plot of this, data, this table, we can make use of bar plot, table, FGRP. So here it gives the bar plot. So this is the bar plot of control as well as treatment. So this bar plot has been generated on the basis of this. Now we can change the labels. FGRP, treatment is the first level and control is the second level. So we can make use of labels. FGRP is equal to C, treatment and control. Now after changing the label, FGRP has become treatment is the first level and control is the second level. So if we here 1 stands for treatment and 2 stands for control, here it has changed the label. And if we make the frequency table of this and we want to make a bar plot, it is like this bar plot of this. So here instead of earlier control was coming here and treatment was coming here, but here it has changed the order. Treatment is coming first because of change in the labels. Most of the times we need, say for example, if we want that first it should show treatment and then control, then it will be like this. But if we want first here it should be control and here it should be treatment, then we have to go for the original bar plot and original here treatment. Instead of this, we can change it to the original, and that is control and treatment. So what we have to do, say for example, here bar plot shows treatment and control. Suppose we want control first, then what we have to do? Here we have to write treat control and here we have to label it as treatment. After changing this, if we are making bar plot, now if we are making bar plot, here the label has been changed. Treatment comes, no, here the bar plot comes here and it looks like control first and treatment second. So this way we can change the label and we can get the result. Now another example, here x is equal to C 111 222 1 2 1 2 like that. Here if we run this command and print this x, this looks like a numeric vector, but we can convert this into a factor vector by making use of the function factor. So xm is equal to factor x. Labels are 1 2 and labels are like label on a medicine. Labels is equal to C, male, female. And if we print this, we are having labels male and female. And here this is the factor vector because it is not coming out in double quotes. Then we can get the table of xm. So here 6 males and 5 females, and we can have a bar plot of this table, and it is like this: 6 males and 5 females. But if we change the labels, female, here male is the first label and female is the second label. Now, if we want to change this female first label and male second label, then we have to use this command, labels go to 1, 2, and labels is female and then male. See, here label has been changed. Earlier it was coming male and female, now it is coming female and male. And table XF, see, there are 6 males and 5 females. So, this is another example. We can have bar plot of these using bar plot function. Now, insect sprays is a data. It is a data, and we can have information about insect sprays. Control 2, help insect sprays, help insect sprays. So, this is insect sprays is a data set. It is in the package. Here this is the object insect sprays, and here the name of the package in which this object exists. So, it is data sets package which is available with base R. Effectiveness of insect sprays, and this is the description of the data. The counts of insect in agricultural experiment units treated with different insecticides. So, here this is the object. If we just type insect sprays, and a data frame like a data matrix with 72 observations on 2 variables, count the number of insect count, and spray the factor, the type of spray, and these are the references of the data. So, actually, if we want to look into this data control, and if we want to look into the tabular form, this insect sprays, So, here this is the data, and to look into the header part, we should make use of the head. First, we will make use of the names. Names stand for column names. Names insect sprays. So, names stand for column name. Count, there is a column of count and there is a column of spray. To look into the header part, we can use the function head insect sprays. So, this is the header part. It shows from the top names of the columns and then first 6 observations. Even if we want to look into just n is equal to 10 observations, we can go into the, so here first 10 observations can be seen. By default it shows 6 observations. So, here count is the numeric vector and spray is the factor vector. So, control 1. Now, to look into the structure of this data, there is a function str in R, control plus enter. It shows the structure of the data. The object is data frame with 72 observations and 2 variables. Count is numeric 10, 7, 20, etc. and spray is factor with 6 labels A, B, C, D, and their numeric version is 1, 2, 3 up to 6. As dot integer can be used to look into the, see here what we are doing, as dot integer to convert into the integer, insect sprays, and we are selecting the column of spray which is a factor variable. So, here it shows the, instead of showing A, B, C, D, it is showing the numeric character, that is 1111 for A, 2222 for B, C333 for C, DD for 4 and 5, 6, etc. So there are 72. Now we can generate the table of insect sprays. So this table, there are 12 A's, then B has also 12, C has also 12, D has also 12, and so these are the replicates in the experiment. So the insecticide A has been given to the 12 and B has also been given to the 12 plots like this. And if we want to make a bar plot of this, make this table an argument to the bar plot, and here it is the bar plot. See, A, B, C, D. So this shows the bar plot of the data. Now we shall talk about ordered factor, that I will talk later, somewhat later, yes. Here we shall talk about order factor. Now a function GL is a function which is available with base R, and if we want to write help GL, see here GL generate, it is in the base package, and generate factors labels description, generate factors by specifying labels, the pattern of their labels. Here GL n stands for an integer giving the number of labels, k is the number of replicates, length is equal to n into k, and labels seek length, order is equal to false. So here these are the, if we want to look into the arguments, the function is args GL, and we can look into the argument of the function. It is very convenient function, just it is showing the arguments so that one can know about the arguments. See, XF is equal to GL 2. There are 2 labels, and those labels are female and male, and K each is replicated how many times? 5 times, and labels are female and male. So this will generate a table, a factor table, and if you print C, female, 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 female 5 times, and then because K is equal to 5, and then other label is male, male, male 5 times, and these are the labels of female and male. If we want to make a bar plot, table, female 5 and male 5, bar plot of female and male, again we can have a bar plot of female and male. Say, if we want to make here male and female here, what we have to do? We have to change the labels. Here it is male, change the label, and that is male and female. By default, it makes alphabetic ordering, but if you want to have your own orders, you have to use the function labels. See, now male has become first label and female has become second, and then table and then bar plot. So here bar plot, instead of coming female here, male comes and female second bar. Another variable, factor variable, and that is income. It can be generated by GL. There are 3 levels of the income. There are 3 levels, and they are low income, medium income, and high income group. and k is equal to 4. So each level there are 4 observations, 4 persons taken. So here it has been generated low, medium and high, and if we want to make a bar plot of this, it is like this: low, medium and high. But actually there is a concept of ordered function also. Here in printing you are just looking into low, medium and high, but there is no ordering. But if you control 2, suppose ordered F income. So here it shows levels, but it changes order also, like low is less than medium and less than high. So this is the role of ordered factor. Ordered factors play a very important role. Like here, it should be low, less than medium, less than high, and it affects on modeling also. So these are the ordered factors. Now I shall talk about listed data object. List has the flexibility of combining different types of data into a single object. This facility is not available with the vector, because if say for example 2 x is equal to c, if you are having 2, 3, 5, so this is a numeric vector. If you print this will be numeric. But if you combine here with x, say for example double quotes male, now what will be the effect? X has converted the whole vector into the character string. It is not numeric now. It has converted into the character string. So that means we cannot do any numeric operation over this vector. So keeping in view these facts, actually the statisticians, the R developers, they given the concept of listed data object, and the function is list. So control 1, here names is a character string, and then score is a numeric vector, and then gender is male, female, like this. We can combine these 3 objects in a single object, and that is LD, by making use of the function list. So list names is equal to names, score is equal to score, and gender is equal to gender. So here this name is the name of the object, and this is the value of the object. This is the name of the object, and this is the value of the object. This is the name of the object, and this is the value of the object. So here suppose we want, here these are dollars, LD dollar names. So this is name here, then score, and then gender. So these are the 3 things. Suppose we want to change names of LD, listed data object. Like there are 3 objects, C, in double quotes we can write names and then we can write score and then we can write gender. So after naming this, if you print LD, you will have changed name. Like instead of names, now in caps lock names has come. So this way you can change the names by using the function names. Now you can extract by using dollar operator from a listed data object, like say you want to extract names only. So names. You want to extract scores only. Alternatively, we can use double square brackets to extract any element, like here LD, then inside the bracket we are using another pair of brackets. So this is the extraction operator of, this is the first object of LD, and if we will get the LD, and that is names. Then LD2, it is the score vector. LD3 is the gender vector. And we can do any operation on these things, like LD2 is nothing but scores. So we can run mean LD2. So it is mean of LD2 vector. Or we can extract by names and we can do operation LD. Any basic operation we can use, like suppose if we want to use summary of LD dollar score. So we can get summary features, not only mean, summary features, like summary here, minimum is 67, first quartile is 75, median is 80.5, mean is 80, third quartile is 87.5 and maximum is 89. So this is the summary feature of a data vector. This is the best summary, and actually this is a kind of, although this is known as 5-number summary, 5-number summary of these. This is the minimum, this is the maximum, this is the first quartile, this is the second quartile, and this is the third quartile. So these 5-number summaries were given by John Tukey, and it is the best summary of a data vector, which is implemented into R. And now in the next lecture I shall talk about matrices and arrays.